Well, we have another question here. Given f of x equal to x cubed minus x squared, minus x squared minus x plus 1. And then the question says, write down, question 9.1 says, write down the coordinates of the y-intercept of f. Okay. It is, the y-intercept simply means make x is equal to 0. Okay. So the function, let me write, the function that is given is f of x is x cubed minus x squared minus x plus 1. So as I was saying, 9.1, we're looking for the x-intercept. X-intercept simply means we're looking for the y-intercept. I mean, y-intercept over here. Y-intercept means make x equal to x is equal to 0. So if x is equal to 0, clearly y will be 1. Or just look at the constant term of the cubic function. Here the constant term is 1, so that's the y-intercept. So therefore, we're just going to say here the y-intercept is 0, 1. Now, question 9.2. The question says, calculate the x-intercept now. Okay, so we're looking for the x-int. Similarly, the x-intercept simply means make y equal to 0. So in this situation, f of x is just like y. So we have like y equal to x cubed minus x squared minus x plus 1. Over here, we're going to substitute the value of y by 0. Okay, and then we have like 0 equal to all this. Okay, now we can we have like 4 terms here. We can factorize this. Okay, notice if I take like x squared over here, I can take x squared as the common factor of the 2 terms. Okay, x squared as a common factor, and then this will be like x minus 1. And then over there, if I take also -1 as the common factor, and then that will be x minus 1. So this will make 0 equal to x squared minus 1, and then x minus 1. I can factorize further if I want. 0 will be equal to x minus 1. If I use the difference between the 2 terms, x squared minus 1 here can be x minus 1 times, can be x plus 1 times x minus 1. And then we have also x minus 1. So this, I say, let me just show. Okay, generates the 2 here. Okay, and then we can calculate now the value of x. So this simply means x plus 1 is 0, or x minus 1 equal to 0. Now if I move 1 there, if we're like -1, or x equal to 1. So those are the x-intercepts. Okay, we have 2 intercepts here for this cubic function. They are -1 and 1. That was question 9.2, and now question 9.3 says calculate the coordinates of the turning points of f. Well, the turning point for cubic functions occurs when the first derivative, or just the derivative of a function, is equal to 0. Okay. I want to move my board this way. Um, 9.3, 9.2. We're looking for the turning points. Okay. X TP and Y TP, the coordinate of the turning points. Now we say that the coordinate of the turning points happen when the derivative of the function equal to 0. So the function is let's just say f of x equal to x cubed minus x squared minus x plus 1. Now, derivative, this will be 3 times x squared. Okay, so I did apply this formula. What is it? I'm gonna write the formula somewhere here. You know, when we have like ax to the power of n derivative, this is like n times a times x to the power of n minus 1. Okay, so reason why I write 3 because of this exponent 3, and then x to the power of 3 minus 1 minus 2 times x to the power of 2 minus 1. Okay, over here the exponent is just 1, so I'm gonna say minus 1 times x to the power of 1 minus 1, and then the derivative of a constant of any constant is 0, and then this will be equal to 3 x squared minus 2x. Okay, because 2 minus 1 is just 1, and then I don't need to write the exponent 1, and then that makes negative 1 because this part here is just equal to 1. That makes x to the power of 0. Okay, this makes x to the power of 0 and x to the power of 0 just 1. So I don't need to, I just gonna say minus 1 here. Then we said that f prime of x is equal to 0. So I'm gonna sub 0 there for x. And now we can solve this. I need to find the value of x. So what I can do, I can factorize this. So I'm gonna look at the coefficient of the first term times the coefficient of the last term. 3 times negative 1 is how much? It's negative 3, right? So let's write here negative 3. Now the factors of 3 are just 3 and 1. Or 1 and 3. I prefer to start with the smallest 1 and 3. So if I need to get negative 2, this is possible only if I write like positive 1 and minus 3. That's the way I can get negative 2. So I will extend the trinomial into 4 terms. Okay, that makes like 0 equal to 3x squared. Instead of me writing negative 2x, I am going to write plus 1x minus 3x, knowing that this is just negative 2x, okay? Minus 1. So say this part is just negative 2x. I split it, I prefer to split into 4 terms so I can factorize by grouping the first 2 and the last 2 terms. So this will be 0 equal to, if I take x as a common factor, okay, and then there I will take negative 1 as a common factor, and then this will be like 3x plus 1, and then that's going to be like 3x plus 1 also. So note that we must get these common. If they're not common either, we choose the wrong factors over here, or calculation somewhere was incorrect. Okay, be careful when I take negative 1 as a common factor. Here it must be 3x plus 1. You can check yourself. Negative 1 times 3x makes negative 3x. Negative 1 times positive 1 makes negative 1. Okay, careful when we take out a negative number as a common factor, because the negative sign affects whatever inside the bracket. Now, now that we got this common, we will say that 0 will be equal to 3x plus 1 and x minus 1. Okay, now this means that 3x plus 1 equal to 0, or x minus 1 equal to 0. Then this means that if I move the 1 over, that makes 3x equal to negative 1, and then dividing both sides by 3, that makes x is equal to negative 1/3, or x is just 1. Now those are the x coordinates of the turning points. We don't stop here, especially when the question says work out the turning points of the function. We need to find the corresponding y value. So I'm gonna move here. Over here, I want to say like for x, okay, equal to -1/3, we're going to substitute the value of x within the function. So it's going to be like, you know, f of x was like x cubed minus x squared minus x plus 1, right? So now we're going to sub in, instead of me writing x, I'm going to sub in a third, okay? Okay, I'm going to sub in there by -1/3, -1/3, -1/3, -1/3 there. And now this will be like, let's use a calculator for that. Can we, shall we? We can just work it out. That makes -1/27, and then that will be negative 1 over, that makes 1/9, because what is in the brackets here will be positive, but with a negative here, still negative again. And then here it makes +1, and then +1, +1/3, and then +1. Now I think we're just going to use a calculator here. Now let's just use, as I said, so we have like -1/27, okay, minus 1/9, 1/9, and then plus 1 over, plus 1/3, and then plus 1. So this is just equal to 32/27, okay? So y will be equal to 32/27. This simply means, excuse me, the turning point here is -1/3. Okay, I prefer to write them all together after one time. And then for x equal 1, okay, so y, which is given by x cubed minus x squared minus x plus 1, y will be equal to x cubed minus x squared minus x plus 1. We sub in there the value of 1 wherever we have x, and then the function here would be 1 minus 1 minus 1 plus 1. Now what we get here, 0, because 1 minus 1 is 0, -1 is 0. So here y equal to, y here will be equal to 0. Therefore, the turning points are 32/27 and up 1, excuse me, -1/3 and 32/27 and 1 and 0. So these are the turning points of this cubic function. And then the next question must be question 9.4 over here. The question says that sketch the graph of f in your answer book, clearly indicate all intercepts with the axis of the turning points. The axis and the turning points. Okay. Now let's, I prefer to move the board this way, this other way. Okay. I think I need this space. You can just move it here, right? And then take this one, move it there. And then this also. Oh. And this. Yes. Now we have space. And then question 9.4. We have to sketch this. The graph of f of x. Now, to do that, I'm doing that by the help of in the Cartesian plane, okay? It may not be mentioned, but You understand when they say sketch, you're going to use the Cartesian plane. So I am going to draw my vertical axis. Okay. Let's draw it somewhere. Draw it there. Okay, and then the horizontal axis, the x-axis. Okay, so that's the y, and that's the x. Now, we found intercepts. Okay, earlier we did find like let's see again how much was the intercepts in equation 9.1. The y-intercept was 0, 1, and then the x-intercepts were -1 and 1. Okay, so in the graph here, so let's say 1 is somewhere here. Maybe I use this. That's 1, and then +1 is here, and -1 is there. Okay, and then what else? The turning points. We define the turning points at 1, 0, and then -1/3, 32, 27. Okay, 32, 27 simply means over here. Oops. This means okay, 32, 27. It means 1 and 5 for 27. Okay, 1 unit and 5 for 27. So 1, 0 is 1, 0 is here. That's 1 turning point, and 32.27 with -1/3. So -1/3 must be somewhere a little bit before -1. Well, I think my graph is like very tight, probably, but not so. Okay, anyway, let's say -1/3 somewhere here, somewhere here, and then 1 and let's take it somewhere here also. Yeah. Now the graph will be, this is where the curves are. No. I think I need to redo. I need to put some space, because otherwise it's not going to be clear enough. Okay, so let's say +1 is, I want to say +1 is here, and then -1 is somewhere there, and then +1 also here. Okay, like that, we have kind of space. Then the points now, those were the x-intercept, x-int, y-int. Now the turning points are -1/3, 32, 27. As I said earlier, this is just 1 unit and 5 over 27. 27. So a little bit more than so if -1, no, that must be somewhere here, and then a little bit up there. Yes, so turning points there, and the other turning point is also over here. So the turning points are here, like that. Now we can draw make turns turning point is here, and turning point is also there, and intercept. So now we can draw like this, pass through the intercept, through the x-intercept here, and then comes like that, passes through the y-intercept, turns here, and then goes up. Yes, that's the graph of f of x. X cubed minus x squared minus x plus 1. Good. Now, the next question is 9.5. Question 9.5. This question. The question says, write down the value or the values of x for which f prime is lesser than 0. Okay. Move this like that. Mm. 9.5. We're looking for the values of x, okay, for which f prime of x is lesser than 0. Now, we did work out f prime of x earlier, and then we had like f prime of x was equal to 3x squared minus 2x minus 1. Now, and then after we did factorize this also, it was this was the solution when we factorize. We got 3x plus 1, x minus 1. Okay, so that means 3x plus 1 and then x minus 1. This is lesser than 0. Now to work out to find the values of x, it's better to draw the number line. Okay, so I'm gonna draw my number line, and then it's the number line. Now the critical values that we find were negative a third and 1. So in a number line, we need to place the numbers in ascending order. Okay, so negative a third is here, and then 1 is also there. Then now we're going to use some I'm gonna pick up values like I'm gonna take away, like we split our number line into 3 intervals, okay, from negative infinity to negative 1/3, from negative 1/3 to 1, and from 1 to positive infinity. Now I'm gonna select any number, okay. I'm gonna pick up a number like let's take a number like -2, for instance, because it is this interval. So if we sub -2 for x there, -2 for x here, this will be negative. And if I sub -2 there also, this will be also negative. So negative times negative will make positive. So if I sub -2 here, I sub -2 there, we get like negative times negative, and negative times negative makes positive. Okay. So this side is going to be positive. Now we're going to select another value here in between -1/3 and 1, like 0, for instance. So if we sub 0 for x there, we will get like this will be positive and that will be negative. Positive times negative makes what? It makes negative. Okay, and then we're going to select also another value, okay, in between after 1, like a number like 2, for instance. So if we sub 2 for x there, and then we will get this will be positive, that will be positive, and positive times positive will make positive. So this side will be positive. Now we're looking for the values for which the derivative will be lesser than 0, meaning lesser than 0 means negative. So our solution is here between -1/3 and 1. Therefore, we can write we can write like -1/3 lesser than x lesser than 1. So this is the solution. Okay. Thank you.